Well, good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speakers, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions, and we will try to get to as many as we can near the end of today's webinar. We also have 3 polling questions during the course of today's webinar, so hopefully we can get everybody engaged. And we are doing a drawing at the end of the webinar for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is Kubernetes reliability, 5 tips and tricks to avoid downtime. Our speakers today are Kendall Miller, who is president of Fairwinds, and Ivan Fetch, who is solutions architect at Fairwinds. Gentlemen, thank you so much for joining me today. Really appreciate it.
Thank you.
Thanks, Charlene.
All right, well, I'm going to put myself on mute. Sorry, Kendall.
No, sounds good.
Just wanted to let everybody know I'm going on mute and off camera, so there's nothing wrong with your system if you see me disappear, but Kendall, go ahead and take it away.
All right, thanks, Charlene. So we'll go ahead and dive in. This is, as mentioned, Kubernetes reliability, 5 tips and tricks to avoid downtime. If you are here looking for something else, you are in the wrong place. If this is what you're here for, you're in the right place. We'll go ahead and dive in. But first, let's start with a poll. Where are you in your Kubernetes journey? So if y'all want to go ahead and pull up that poll.
Yep, I'll go ahead and push it out right now. It should be showing up on your screen. The question is, where are you in your Kubernetes journey? You can select from, I'm learning about containers in Kubernetes. I have spun up a test cluster. I have started using it in pre-production, or I am using it in production. Hopefully we get a lot of people who are actually using it in production. Go ahead and make your choice. And while the audience is making its choice, I just want to make a quick reminder that at any time during today's presentation, if you have a question, you can go ahead and use your GoToWebinar control panel. You do not have to wait until we get to the question and answer period. All right, guys, I am going to go ahead and close out the poll in 5, 4, 3, 2, 1. Okay, it's closed. Let's take a look at the results. Oh, that's an interesting breakout. Looks like 37%, the largest number, are learning about containers in Kubernetes, but followed very closely by I'm using it in production at 31%. So we definitely have both ends of the spectrum there.
Right. Awesome.
Yeah, with a couple of folks in between. That is actually interesting. For most of the poll, I was watching as numbers were coming in, and the I'm using it in production was actually winning, which I was going to be surprised at. This does line up with about what we've seen before. So
excellent.
All right.
Results. There we go.
Yeah, thanks, folks. That helps us frame a little bit of how we proceed in this discussion today. So by way of introduction, as mentioned, my name is Kendall Miller. I'm president at Fairwinds. I was the first hire at the company. I've been here for 5.5 years. We've been doing Kubernetes exclusively for about 4.5 of those years. Excited to be here to talk about this with you. And Ivan, you want to go ahead and introduce yourself?
Sure. Hi, my name is Ivan Fetch. Thanks everybody for joining us today. I'm a solutions architect. I've been with Fairwinds for a little over 2 years and doing Kubernetes for about as long, and look forward to diving into this content today and hope to get some great Q&A dialogue with some of you all at the end.
Right. So real quick at a high level about Fairwinds, we are a Kubernetes enablement company. So everything that we do is around helping companies succeed with Kubernetes. And we do that through a variety of software, open source, and services. So our software we'll actually be showing a little bit of later today is a configuration validation and policy enforcement platform. We also have a whole bunch of open source because we in our services, build and maintain lots and lots of Kubernetes infrastructure in production. We see what are some of the common problems that people run into, And a lot of those problems we go and solve with an open source tool to give to our customers or to enable us and our services. So if you're using Kubernetes, we probably have something in this space, be it open source software, a free tier of SaaS software, all the way up to paid software, and services where you can say, hey, make my Kubernetes problems go away, and we can build and maintain that for you. So that's who we are, and that's why we're here to talk about this, is we do a lot of that at Fairwinds. As mentioned, please ask questions as we go along. Here's our agenda today. We're going to start with this introduction we already went through. We'll talk a little bit about infrastructure as code. Then we've got 5 problems lined up: simplicity versus complexity, because everything in operations is a trade-off; HA architecture; resource limits and autoscaling; liveness and readiness probes; and then setting policy to maintain your standards. And then we have a brief demo of some of our software and what it enables in this space, and we'll talk about recommendations and next steps, and hopefully wrap up with enough time for Q&A. So let's dive in. First of all, this is part of what we're trying to avoid, right? It's been a long time since you've seen Amazon say down temporarily, service unavailable, and that's because if Amazon went down even for 5 minutes, they would lose lots and lots and lots of money. And increasingly, as the world runs on the internet, we need services that don't get over capacity and are reliable. And so we're going to be talking about that today. And I always love the Twitter fail whale. If you're old enough to remember what that was, it's one of my favorite icons of a service so successful that even their failure mode became an icon. But let's start with infrastructure as code. Ivan, you want to start a little bit of why does infrastructure as code even matter?
Yeah, definitely. So this is essentially managing your infrastructure using code instead of humans manually making changes. This could be networks, load balancers, GitHub repositories, Kubernetes clusters, the configuration of those clusters, many things that are able to be configured through an API that can be managed now using code. Servers and virtual machines don't live for months and years necessarily anymore as they once did in data center life. And with clouds being more API driven and VMs living more on the order of days or hours, and it's a very different world. We're not having to depreciate hardware. We're paying for cloud resources, and in terms of hourly now. So we can't manage that process using a more traditional ticketing process and what I sometimes call and have seen called click ops, clicking in at some UI somewhere to operationalize something. So this is representing your standards and your process as code. And there's a few benefits I'll go through quickly on that. And those are repeatable and make something automatable. These reliable results are going to also bring you more standardized environments, the ability to spin up temporary environments, which means more testing and less impact to production. So as you want to determine whether something is going to be possible, a change that you want to make in production, you don't have to wonder about it. You don't have to test and prod. You can use your infrastructure as code to spin up a brand new environment that is very like production. Also, this code serves as a place for you to track changes and audit those changes that you make to your infrastructure. You can consult that code instead of consulting individuals for the history of your infrastructure and also the what and why of your infrastructure changes. Ideally, that why is reflected in comments in your code and in your commit messages. So it's a little bit about infrastructure as code. I think it's a really important underpinning to all these other things that we're going to talk about.
Yeah, we're going to get into a lot of high-level things to build reliable infrastructure with Kubernetes, but there are a surprising number of companies out there who have not yet even gotten to infrastructure as code, and this is something of a prerequisite for a lot of things cloud-related, and particularly reliability. And I'll just add, it definitely removes single points of failure in people. Ivan touched on this, but there are a lot of companies where if Joe leaves or Jane leaves or whoever it is, the company is totally in trouble because that's the only person in the company who remembers all the buttons that need to be pressed to build the infrastructure. And if that's where you are, you have a significant single point of failure. Okay, let's go ahead with poll 2 before we get into the next pieces. What are the biggest challenges that you're facing deploying Kubernetes?
All right, the polling question should be on your screen now. What are your biggest challenges to deploying Kubernetes? You can choose from getting to production, the reliability or availability of kube-hosted applications, assigning appropriate minimal permissions to access, branch-based temporary app deployments for developers, or something not listed here, I'll post it in the question and answer section. So if your problem is not, challenge is not listed here, go ahead and just put it in the question and answer tab, and I'm sure Kendall will take a look at that and address it appropriately. Also, while we are waiting for everybody to make their choice, another quick reminder that today's event is being recorded and will be available after the webinar ends on demand, and we'll be sending out an email that contains a link to access the webinar on demand. So if you miss any or all of it, please know that all is not lost. You will be able to access it again later on. Okay, we'll go ahead and close out the poll now and take a look at the responses. And here we go. What are your biggest challenges to deploying Kubernetes? Looks like the big winner here is getting to production. Kendall, Ivan, what do you guys think about these? Yeah,
getting to production at 34%, and branch-based temporary app deployments coming in second place at 22% is interesting. We definitely see a lot of people who are moving from, say, paths like Heroku or something, see that this is a thing they're used to, and building something that replicates that in Kubernetes is a little bit more complicated and difficult.
Excellent, excellent. Looks like we've gotten a couple other responses in the question and answer tab too. So just a heads up for that. Okay, I'll go ahead and hide the results. Let you get back to it.
Okay, sounds good. Let's keep going. So let's dive into number one, simplicity versus complexity. So as I mentioned, everything in operations, anybody who works in operations knows you're constantly butting up against trade-offs in everything, and everybody wants a really simple, a platform that is as simple as can be for the sake of all of their engineers, but complex enough to meet all of their company's needs. And let's talk a little bit about some of those trade-offs, Ivan. Maybe start with service discovery versus traffic routing.
Sure thing. So service discovery, what it is you have user-facing DNS for access to an application is still going to point at some kind of ingress point, behind which your application is constantly in motion. So if your application is hosted in Kubernetes, running in containers, hopefully it's becoming more and more cloud native or 12-factor over time with development cycles. And your application is going to be moving across different Kubernetes nodes, and it's going to be regularly scaling up and down. So service discovery is built into Kubernetes. There's also other third-party solutions that offer similar functionality, and it's allowing that application to still be reachable as the number of containers that you're running and where you're running them is constantly changing. This compared to a more classic version of traffic routing, which is where you've got applications that probably still involve a load balancer, but it's a little more static. You're pointing DNS at an IP address that might be floating, and you're not able to be as quote unquote agile with where your app lives and how much of it is running.
And this goes all the way back to when you're managing everything in your own data center, and you have one service running on one computer, and you point all the IPs that need, hardwired to that computer if you need to manage that service, right? So this is how that has upgraded through cloud time and space. Yep. Config maps and secrets versus old style application config and configuration management tools. Can we talk about some of those, Ivan?
Definitely. The goal here is to keep your application configuration abstracted from your container image. So this makes images portable across different environments like staging or production. And also those same images can be used by developers in development cycles and for local testing as well. Config map and secret resources in Kubernetes are the places that you can store this configuration information, and you can make it available to your application either using files or by exposing them in environment variables that the application can read. You can also secure config map and secret resources separately from other resources that live in Kubernetes using RBAC or role-based access control. So if you want to make sure that in a staging or a dev environment, maybe developers and other folks have access to those resources because testing is happening, but they don't have access to secret resources in production. That can all be controlled with RBAC. As far as the configuration management bit, as you're moving into the world of containers and orchestrating and hosting those containers in Kubernetes, it can be understandably tempting to capitalize on an existing investment of configuration management, so something like Puppet or Chef or Ansible. The issue here is that doing that, while it might initially feel like a win, can add additional complexity. For example, time that it takes to build your application image, which means your recoverability from an unexpected issue or deploying something that turns out to introduce a bug in your application can take longer because you've got these additional layers that you've kept in the mix. These extra layers can make your cloud native transition more challenging, and ultimately we recommend you replace your typical application server, virtual machine configuration, and typical golden image with containers. This essentially means that containers become the quote unquote application artifact. And of course, your nodes are more ephemeral. Your VMs are part of your Kubernetes cluster. And you're not building app servers anymore with config management like we once were.
Yeah, and what we were doing with configuration management back before Kubernetes was largely writing big, complex configuration management tooling to orchestrate all the things, which is now what Kubernetes does. And so we've moved on to a next world, and in theory, another layer of abstraction, which is a big deal. So let's move into HA architecture. Maybe at a high level, what is HA architecture? Why does it matter? And then I want to talk a little bit about how it was done before the cloud was an option.
Sure. So really we're guarding against downtime or failure of some component. So we might have
failure is going to happen, right?
Right. So we might have increased demand on your application. We might have, so more people want to use it because you just hit Hacker News yesterday, or we might have some kind of failure in your stack or your application. The goal here is to distribute work across multiple instances of a thing, probably using a load balancer. Or you can do that a slightly different way by having a standby instance of that thing, which tends to be a little bit less graceful to cut over. And then as far as fault tolerance, it's very similar. It's continue to operate when something fails. And I think you wanted to talk a little bit about how this worked pre-cloud, Kendall.
Yeah. Well, so even like now, when we talk about HA architecture, a lot of times we're talking about building across availability zones in a cloud, right? So we're going to be in US West, but we're going to be across 3 different availability zones. So that way, Amazon builds it so that if one of those availability zones for some reason lost power, the other availability zones, even though they're in the same region, are powered by something else, have a different internet connection. There is there are failure modes that can be, there's backup systems, I guess, is the wording to put there. Like, think of an airplane, always having multiple redundant systems so that if one system dies, you can still control the airplane. That's the idea. And pre-cloud, what you had to do was basically have everything running in a data center and then in another data center not far away, or that data center had to have multiple pieces of that data center being powered by different things with different internet wires coming in, just in case something went wrong, so that there are fault tolerant systems. Did I get that approximately right, Ivan?
Yeah, definitely. In the data center world, we would see these fault domains as UPS for power, generators also powering that UPS if we lost power from the utility company, switches, routers, cooling systems, power supplies in the racks, what we call power distribution units, all of these things that could break in the big long chain of equipment that allows our servers and our things running on top of them to continue operating. And so that's what the cloud providers are representing, these failure domains, in terms of what we call availability zones today. So it's all, of course, the same thing being managed, but by someone else, which is excellent.
Okay. Well, let's keep going, and for the sake of the audience, I do see some questions coming in. Keep those questions coming. I will get to them if they're immediately relevant and/or as we get to Q&A towards the end, but feel free to keep asking questions. Number 3, we're talking about resource limits and auto-scaling. And interestingly here, again, we're going to get into a little bit of Fairwind's software here in a minute, but we do see lots of companies that are leveraging our software. In fact, 25% fail to specify CPU or memory limits. And we also see 15% have over-provisioned resources. So that's significant and something we have insight into that is a macro trend that people have a difficult time getting these things right. But talk about why it matters for reliability, Ivan, to get resource limits and auto-scaling right.
Yeah, so first, the outer question is, why does auto-scaling even matter in the first place? We're talking about this on 2 levels. One feeds the other. The first is you want your application to be able to scale. And typically that's going to be scaling on some sort of metric based on demand of your app. And ideally, it's a metric that is meaningful to your app. Hopefully something slightly less ambiguous than maybe CPU or memory, although we do see those as common metrics. If your app processes data off of a queue somewhere, then it's great to monitor that metric to decide when you need your app to scale so that it can continue to handle more of that data as there's demand for your app. And then as your app continues to scale, you also are going to need to add nodes to your Kubernetes cluster. So the nodes you have get full, and your cluster can spin up additional nodes and continue to scale up that way. So both of those things work in concert with one another, which is where resource requests and limits come into play. Resource requests say, here are the amount of CPU and memory that I expect my application to need. And that matters in terms of Kubernetes deciding, excuse me, which node your application should run on. And then there's also something called resource limits, which is the upper bound of that, which says how much memory and CPU is my app maximally allowed to use. Ideally, those numbers are identical, the requests and the limits part, or they're very, very close. And what we see as well as, like you said, Kendall, customers that may have no resource requests and limits set, which can cause apps to sort of do whatever they want and potentially overwhelm Kubernetes nodes. But sometimes we also see a big separation between the requests and the limits, which means that something might be scheduled at a low resource request, and then it's able to use much more resource than is specified in the request because the limit is considerably higher, which means it's capable of having many apps running on a node that can overwhelm that node. So we have software and we have expertise in this world of Kubernetes hosted apps that can definitely help you get those tuned right.
Yeah, and some of this is in our SaaS software, but if you're looking for an open source solution that helps with this, we have a tool called Goldilocks. You can Google Fairwind's Goldilocks and that'll come up in GitHub, but that will help you get these things right. It will actually watch what your application's actually using and make recommendations based on that. And let's get into liveness and readiness probes. Well, wait, I want to say one more thing about autoscaling. So the beauty of the cloud is you don't have to have a data center with all the computers in it that you're ever going to need. That's the beauty of the cloud. And as it relates to reliability, you can build a system that is highly reliable, but using what your actual usage is. So rather than having to build a massive data center that can handle your biggest load in the whole year, the constant example is Black Friday for a e-commerce site. Instead of having to have a data center that can handle Black Friday when you really only have one Black Friday a year, you get to build something that is reliable at a very low scale, and that's what you actually spend for most of the year, and is reliable on Black Friday because it's capable of scaling up, preferably in an automated way, meeting all of the requests that come in because you've set everything right, and then scaling right back down so your costs aren't astronomical. That's the promise of the cloud, and it's tied directly to reliability here. So anyways, liveness and readiness probes. So this matters for a whole host of reasons, but it's hard to be reliable if you don't know that something actually went out, right? So talk a little bit about this, Ivan.
Yeah, so this essentially helps Kubernetes know what state your containers are in. And there's two primary distinctions with liveness versus readiness. So readiness says, is your container ready to receive traffic from some user via the quote unquote service in Kubernetes that's sitting in front of your application. And this doesn't just apply to when your container first starts. This probe continues to execute, and if your container later becomes unready to where it shouldn't be receiving traffic, then this probe will fail. And the probe in both these cases is either hitting an HTTP endpoint that your application makes available, or potentially running a command inside the container. The second kind of probe is a liveness probe, which is different in that it's asking the question, is your container healthy? This is to guard against situations where containers might become quote unquote stuck or frozen or deadlocked, or they're not doing the work that they should do, but they're technically running. There is some kind of process that's executing, but the container's not actually serving what it should serve for your application. Like before,
this is like my computer is on and working, but it's frozen, and so when I click on stuff, nothing's working, right? I mean, it's a little bit akin to that. Okay.
Yep, exactly. And so your application needs to make something available to query, like I said, either an HTTP endpoint or some kind of command that can be executed inside the container to check for these two conditions. There's also a third probe that's essentially a startup probe that's not used as commonly that helps you determine when an app is ready, when that app takes an inordinately long amount of time to start up initially. So you might need to do a little bit of development work if your application doesn't have an HTTP endpoint that could be queried for these two probes. There's some debate and some discussion sometimes required about whether it should be the same endpoint for liveness versus readiness, but you want to make sure that whatever endpoint Kubernetes is going to query for these probes, which could be queried as often as every second, that it's not a quote unquote expensive endpoint. So you don't want it to be run a whole pile of database queries and do a bunch of work behind the scenes to where that probe could actually cause problems of its own with your application. So you want these probes to be pretty lightweight in terms of how it impacts your app.
Yeah, great. And for clarity too, we have some statistics on this that we see 31% of deployments lack liveness probes and 29% lack readiness probes. So this is something that you can set as a standard with the tool to make sure that everything that's being deployed into Kubernetes has liveness and readiness probes set up.
And what those numbers mean effectively is that the folks that happen to be in that percentage have applications that are in some way less healthy than they could be, and users of their application are still potentially reaching that app. And by reaching that app, I mean they're accessing a container that's not really ready to do any work. And so they're getting, perhaps a 503 error in their browser or some kind of particularly slow service. And so we really want to help avoid that by getting those probes tuned so that apps that are less healthy get to drop out of the mix, they get to take a break, or they get to be restarted by Kubernetes so they can be healthy again.
Because you can wash your hands and say, okay, it's up, it's working, but really your users are having a terrible experience and nobody wants that. That can cost you money and cost you clients. Okay, number 5, set policy to maintain your standards. So there are, we've talked about all of these different things that can be problems, and this is what we've been touching on, is you can build policy to enforce these things so that your infrastructure is built and the applications that are being deployed into it are reliable. And the more reliable your infrastructure is, the less bad time your customers are going to have, the less your customers are going to churn, the less they're going to hit something that's a 503 error, and the more you're going to be aware of how your infrastructure is actually performing. So setting policy to help you maintain these standards is significant. And we also note that there are certain companies that have to meet certain policy standards for compliance reasons, right? There's also if you're going to, how do I say this? We talked to a financial services company recently, and financial services is a highly regulated industry, who has made a decision that they want anybody in the organization to be able to spin up a Kubernetes cluster, anyone in the organization. and kick the tires. That's huge risk unless they have some way of enforcing policy across all of those clusters, especially at a financial institution. And so you need to have policy that is enforceable in a repeatable way across your organization. Otherwise, you have to have an ops team that has a lockdown on every single thing that is built. And you don't want to do that because that's not scalable. And finally, making that a little bit more scalable is a lot easier if you have policy enforced as code. But anything else you want to say on this as it relates to setting policy to maintain standards, Ivan?
No, let's keep going.
Okay, excellent. I like it when I take the whole slide. So we're going to talk a little bit about things that you can look for in a purpose-built platform that helps with these reliability issues. So number one, there are a lot of great open source tools out there in this space that do these things, that check for one piece of this. And what we see a lot of companies do is gather all these open source tools together and try to build a single place where all of this information comes in, but then they struggle with prioritizing what is the high value things, how do we go about improving that, etc. It's also nice if whatever your platform is that you're using for these things has built-in integrations with the tools you're already using, be that your CI process, be that Slack. There's lots of places where your developers are already interacting, and giving them one more thing can sometimes be too much. Do you want to talk about some more of these, Ivan, or do you want me to keep going?
No, keep going.
Okay, so containers, deployment configuration, and cluster risks. There are lots of risks involved in standing up and deploying things into Kubernetes. Are the images that you're using out of date? Are there known CVEs and you're still deploying things into a cluster that has known CVEs, or using applications that have known CVEs, or third-party tools? And staying on top of that is difficult. Next, remediation advice in product and through support. So when you're looking for a purpose-built platform, it's one thing to have a tool bubble up all the problems that you have. It's another thing to know how to go solve those problems, right? So you want a tool that actually tells you how to fix things, not just what's wrong. And then also, finally, an agile roadmap to adapt to an evolving cloud-native ecosystem. So you can build the world's best platform right now internally using the best tools that has all of these things, but the cloud-native ecosystem is moving very, very quickly. And if your system doesn't adapt to what's going on, how it's improving, where things are changing, it's going to be hard to keep up. So we see companies solve a lot of these problems with one of two things. Like I mentioned, they either go out and get a whole bunch of best-in-class open source tools and try to build a platform themselves, or they can leverage some kind of third-party tool. And obviously, we want to tell you about ours. And I'm going to give a brief demo here, and then we'll get to some questions, because I think some of these questions can be answered by the tooling as well. But we have a software tool that I'm going to show you a demo of here in just a second that is policy-driven, does configuration validation, runs multiple open source auditing and policy tools, enforces custom policies using OPA, which is a sort of industry standard in the space, and integrates into your DevOps tools like CI/CD. It has an admission controller. It can integrate with your ticketing systems and Slack, and it can run in any Kubernetes cluster, on-prem or any cloud. And anything you want to say about it before I just jump into a demo? I know I'm doing a lot of the talking here.
Yeah, while you're moving into the demo, I'll just explain briefly that the significance of the admission controller part in Kubernetes is that even if you're also using this to help detect issues as part of your CI/CD pipeline, the value of having an admission controller and what that is in Kubernetes is essentially it's the last resort, if you will. So when something's about to be deployed or applied to your Kubernetes cluster, it's actually the Kubernetes API server running a process or a hook, if you will, and it's tying into this same product as well. So it's the API server rejecting the application of, let's say, a deployment resource in Kubernetes that violates the standards that you've defined in the tool or as policy. And why that's useful, even if we're using CI/CD as well, is that have engineers or folks that might have administrative access to Kubernetes and might have the ability to deploy things outside of what a different group of folks is going to use CI/CD for. So it's valuable to have both, and it helps you maintain your standards and your policies across all of your clusters, no matter how things are getting deployed.
Yeah. Okay, well, let's dive in real quick. This is going to be a very brief demo. I'm just going to show you a high level of what this tool does that Fairwinds has built with Fairwinds Insights, and then we'll get to question and answer here at the end. So real quick, we have built this tool leveraging a whole bunch of open source tools, and several of these are tools that we've built. Polaris, Nova, Pluto, Goldilocks are tools that we've built. Goldilocks is the tool that I mentioned that helps you get resource requests and limits right. That Ivan touched on why that's important. It also leverages OPA for custom policies, and then also pulls in best-in-class open source from third-party vendors such as KubeBench, Trivy, KubeHunter, KubeSec. So whole bunch of reports that we're aggregating into one place, and we give you a breakdown in a single pane of glass that you can have multiple organizations, you can have multiple clusters. I've dove into one cluster here, and we're breaking things down by namespace here on the left, according to security, efficiency, and reliability. Right now in this cluster, we don't have any danger items on the reliability side. We do prioritize danger versus warning. So I'm going to dive into security to show, but reliability would be the same kind of thing that, and let's see if I can add reliability to this too, so we can just show you what that looks like. So now we've got this list of 106 action items of things that need to be improved in the cluster. And 106 may seem overwhelming. That's why we've categorized into priority, and you can focus on knocking out the danger items. We also mentioned which report we're pulling in these issues from. But you can click into any one of these issues, and it's going to actually tell you, first of all, what the problem is, and then importantly, the remediation steps. So how you can actually go about fixing this. So the reason that matters is you can give this tool, and again, there is a community edition of this that is free. So wherever you are, if you're using Kubernetes of some sort, this can help you improve your reliability posture. You can have a more junior engineer dig into this and figure out how to improve things. And again, on the resource requests and limits side, this is what this report looks like in the workload section. You can click on an individual deployment or service and hop into what are the resources that are being requested. This is how much it costs you. This is what it would cost you with our recommendations. And you'll notice here there's a not insignificant difference. $10 per month isn't a big deal unless you have hundreds and hundreds of pods running on this, then it becomes a very big deal. And we are going to actually tell you by clicking on that service, what you should tweak in order to improve this. And sometimes it will actually tell you it's under provisioned and you should be spending more money on that. So there's a whole bunch in this platform. I'm not going to go into all the things. I'm just going to show you one more piece. We do have, as mentioned, CI integration. So let's say you are trying to deploy something into Kubernetes, or your engineers are trying to deploy something into Kubernetes. They don't need to have access to anything other than what they're doing in GitHub, where they're already probably living, or GitLab, or whatever tool you're using, it can integrate. And this is trying to run a container as root and add insecure permissions to a container, and you'll see that it passed Circle CI tests but failed the Fairwinds Insights tests. You can click on details, and it will take you right into the Fairwinds Insights dashboard and show you what broke, why this did not pass, and again, that remediation. Here's how you go about changing that so that it will meet your company's standards. So there's different tweaks you can put on this to raise the standard within your organization. There's ways you can write custom policy, all kinds of things here, but reliability is hard. Security, efficiency, all of these things are tied together, and it's all based in correct configuration, and getting that configuration right is difficult in Kubernetes without help, and that's why this tool exists. So you can check that out, Fairwinds Insights. That was the demo. Let's go to one more, our final poll, and then we'll get into the Q&A. What is your most important reliability challenge? Go ahead.
All right, sorry about that. Should be up on your screen now. What is your most important reliability challenge? Select from assigning appropriate CPU/memory to app containers, responding to increased demand by scaling apps or Kubernetes, user traffic reaches app containers that are not healthy, infrastructure or monitoring are manually configured, or maintaining best practices across apps and Kubernetes clusters. Excuse me. You can also, if your biggest challenge, which apparently for me is talking, your biggest challenge is not listed here, sorry, you can go ahead and just put it in the question and answer tab. And I'm sure Kendall will mention that one as well. I'm dying over here. Sorry about that,
no,
guys.
it's okay. You're doing good. And I'll just narrate some of the what's coming in. We're seeing we've got about 50% voted, so a couple more people vote, and then we'll close the vote up. And but this has given us a good feeling. There seems to be a relatively good spread, although there's one that's winning out, and I don't want to tell you what it is before we close.
All right. Well, I will. Excuse me. We have more than half. So I'm going to go ahead and close the polling question here in 5, 4, 3, 2, 1, as I get all choked up on this, and we'll take a look at the results. And go ahead, Kendall. You can.
Yeah, so we see maintaining best practices across apps and Kubernetes clusters in with 38%. That's the #1 thing. And then it looks like the others got pretty even spread. And I guess, maintaining best practices across apps and Kubernetes clusters is relatively encompassing of all the other pieces. So if you're dealing with more than one, that's probably why that came up. But I do think Kubernetes is a whole new world. It is a whole new paradigm. It is different than the way that we have interacted with the cloud or data centers in the past. And it's not that it's much more complicated. It's that it is a whole new paradigm. And until you've learned the new paradigm, it feels overwhelming. And that's part of why we've built this tool, is because we know people struggle with getting things right. So you can go ahead and wrap up the poll, and we'll keep going here. So we've just got one more slide here to say, go check out Fairwinds Insights, insights.fairwinds.com. There is a free month trial of the full thing, as well as a community and the free edition. There's also premium editions. And let's go ahead and then dive into some of the Q&A. So as is always the case, we get a question about databases running inside of Kubernetes. So Ivan, talk a little bit about, here's the question: what is the best approach to running databases like MySQL, replication, MongoDB sharding on Kubernetes, and similarly, running MongoDB sharding on Kubernetes. That's so it came in twice. I guess it's running MongoDB in Kubernetes and also handling the sharding, but the sharding is maybe a whole separate question.
Yeah, so I'll talk about a couple points on this, and I believe that we are going to have some future content that also will address some data topics in Kubernetes in the coming months, if I'm not mistaken. So keep your eyes out for this landscape on that. But a couple things I can say about this topic is that we recommend that, especially as folks are getting started in their Kubernetes journey, that they don't add the complexities of having to manage data or state in Kubernetes at this point in their journey. So that's not to say that it isn't possible. And of course, there are resources in Kubernetes that facilitate you having storage and so on. But what we've seen and found is that doing it yourself, especially when you're just getting started, can be pretty daunting. And that leads me into my second point, which slightly more addresses the question at hand, which is in terms of the approach. So from a cloud perspective, the challenge with having multiple replicas of some kind of database in Kubernetes is that the volumes that you end up using are tied typically to your availability zone. So that's that failure domain or that fault domain that we talked about earlier. So you need to make sure that you organize your Kubernetes stateful set resources, which is essentially like a deployment resource, except it's tied to a permanent volume that the volume persists. So it's persistent storage, and then if that stateful set gets scaled down and scaled back up again, it has access to that storage again. So you want to make sure that you organize those stateful sets in such a way that if you've got an availability zone failure, consider the failure domain or the HA picture of that story. And what I'm getting at here is that because you can't move volumes across availability zones typically, there are some potential challenges that you want to really test for and look for when you architect this solution around, if I lose an availability zone, how many of my shards or how many of my replicas am I going to lose? And what's my recovery that probably is going to involve me scaling up the other stateful sets in my cluster that represent that same data source in the surviving availability zones. So I realize I've said a lot of words there. I apologize for not being able to dig in a little more deeply, but hopefully that helps give you something to go on as you dig more into how to design that.
Yeah, thanks, Ivan. So one person said, and this is back at the poll of what are the most difficult things to getting up and running with Kubernetes, and this person said, my problem is getting staff trained so that everyone is comfortable and proficient with Kubernetes. So I have a couple of thoughts on this. Number one is, like, the easiest way to get people comfortable with something new is to have them go use it. And so, you know, that's easier said than done. I recognize you stand up in an environment and say, go kick the tires. People aren't going to want to do that because it's probably not their production environment. It's going to be one additional thing that's overhead. Fairwinds does provide training. Actually, Ivan helps with some of that training. It's specific in certain buckets if that's something that you want, but that's something we could talk about. I would encourage, you know, hiring a company like us to build an infrastructure and maintain it for you to get started. And we do a lot of knowledge transfer in that process. So once your production environment is built and there are ways to deploy into it, now your developers have to get comfortable with it because that's what the production environment is. But we've made it very easy for them to dip their toe in. And as they want to learn more and more, we help ease that process. So that's one of the ways to do it, is hire somebody like us to build it, maintain it, and then you can learn by osmosis with us de-risking it because we're actually responsible for keeping the infrastructure up. And we're going to be responsible for making sure your team is addressing best practices. Now, the other option is using a tool like Fairwinds Insights that's going to expose to your engineers what the best practices are. And honestly, you can make it that the deployment process looks the same as wherever you're deploying today. They sit in GitHub, they issue a pull request, and CI kicks off. And then Fairwinds Insights sits there to tell them, hey, this is a new paradigm and part of Kubernetes, or this is part of the policy that you as your company have written, and until you fix this, you shouldn't be able to deploy. But that way, you know, the developer's experience doesn't change very often, and your operators actually have some confidence that they're doing things right. Because yeah, it is a new world. Getting your staff trained and comfortable is difficult because this is all new. We have some things that help make this easier. So if you want to know more about that, we're happy to get on the phone and talk. But take a look at that. So then we have a question about Fairwinds Insights. Does it help in auditing and compliance? So the short answer is yes. The longer answer is it depends on what your auditing and compliance needs are. There are a tremendous amount of checks out of the box with Fairwinds Insights that will help you get to an audit comfortable space or a compliance compatible space. If you need specific checks written for compliance, that's something that we actually can help with. So if you buy Fairwinds Insights and you say, hey, we also need these 10 checks, we can help you write some of those things as a part of our service in selling you the software, is writing custom policies for you, particularly if you're doing it at scale. And obviously, the larger the ticket item is that you're paying for the software, the more we're happy to help you get it customized and working for you. So it will help with auditing, it will help with compliance if those are specific needs that you have. You need things that are running all these checks and checking these boxes and giving you reports that help you reach those compliance standards. And this is a tool that helps you do that across all of Kubernetes, across security, across reliability, across efficiency. Getting configuration right is the #1 way you avoid security problems. So, you know, configure your things right. Okay, advice to handle readiness probes for API containers. For example, a busy API endpoint used by a probe doesn't respond fast enough, and the probe eventually kills the pod.
Okay, so I'm going to guess that this is probably referring to a Liveness probe, because a Liveness probe is actually the thing that's going to kill the pod, you know, restart the container in the pod. The readiness probe will cause that pod to no longer receive traffic, which actually might be more what you would like to happen. And so there's a couple suggestions that I can make here. Normally this would be a deeper conversation that we would have. Since we can't have that conversation right now, I'm going to throw a couple things out there as we wrap this up. So you might consider having that check that you're currently using be a readiness probe if it's not already, so that if the API becomes too slow or becomes overwhelmed, you stop sending traffic to that particular pod. That's one thing. The other thing to look into is, what is the situation in which the API is responding too slowly? If it's that way all the time because the API is doing a lot behind the scenes, it's a quote unquote expensive or a busy API, you might consider a couple of things. One of them is, could you have your health check that's being queried by the Liveness and Readiness probes query an endpoint on your API that does less things? So the API being ready, maybe that probe is too expensive, and so maybe you query something else. The other thing to consider is, if you're already querying a very inexpensive endpoint on the API and it's still becoming too busy, trying to get more to the bottom of that from your code perspective. Maybe you, if this is a very busy API, to go back to that as the last point, if the API just does a lot behind the scenes, you can simply increase the timeout that the probe takes. The risk in doing that is, if you increase it to more seconds, then you could be causing users to reach an available API for that same number of seconds. So there's a trade-off there. So there's more discussion and nuance to dig into to help solve this, but hopefully some of those points make enough sense and give you something to go on there.
Great. And we're going to wrap up here, and I can turn back over to the DevOps folks in just a second, but I just want to say, if you want to go kick the tires with Fairwinds Insights, there is a sandbox environment on our website. There's a link in the slides when you get those, but also if you go to Fairwinds Insights, our website, there's an option to just drop into the demo environment, so you don't need to install an agent. It is that simple. Installing the agent takes about 5 minutes. You get a whole bunch of reports very, very quickly, but you don't have to do that to kick the tires and take a look at it. But alternatively, if you want something else, we do have a guide to Kubernetes reliability that is downloadable, is free, and you can go check that out, fairwinds.com, click on resources, and you can find our guide to Kubernetes reliability. It was actually written by Ivan Fetch, who's on time. And thank you everyone for attending. Oh, it looks like there's one more question that came in, so let me see if we can address that before we run out of time here. We have three master nodes with Kube API server static pod running in each master node. How do you normally ensure the availability and resiliency of Kube API server static pods? Any best practices for configuring its manifest file, GC, or resource protection, etc.? Is that, I stumbled over that question, Ivan. Did that make sense to you?
Yeah, I got it. So I'm rereading it also real quick, sorry. Okay, so how do you normally ensure the reliability and resiliency of these pods? So this is probably already something you're doing, but just to make sure that it's covered, is that you want to load balance access to your Kubernetes API. Some cluster architectures have one of your three masters as a quote unquote primary. So one of your three control plane nodes would be the thing that folks are actually talking to, and then the other ones are sort of there as a hot standby. We recommend instead making sure that you've got a load balancer in front of those, so that your requests are being spread across those masters, or those primary control plane nodes. The other thing to look out for is that you may have something querying the API very, very frequently. And so this could be a need for you to have your control plane nodes running on more powerful VMs. That's a possibility. If you see very, very high CPU usage, try to look at your audit logs on your API server and determine whether something is extremely busily querying that API server. That does happen. In terms of the second part of your question around resource requests and reserving resources, you can play with the resource requests and limits for the API server You can also do there's some other categories on the control plane nodes that allow you to reserve resources for particular buckets of things. So you can reserve resources for system things, which would be like SSHD running on your control plane. That might be a little part of what you're getting at there. And in all of those cases, though, you want to be careful how you tune this. So if you are setting resource requests and limits on your API server and you want to raise those because you know you need more resources, try to raise the resource requests and limits in concert with one another. Try not to leave a big gap between them. So, and this is somewhat dependent on what you're using to manage your clusters. And so I can't get into too much more detail. And I know that we're tight on time, but hopefully some of these points help you with that.
Thanks, Ivan. Thanks, everyone, for questions. And Charlene, I'll turn it back over to you for the moment everybody's been waiting for, the gift card run.
I'm sure that's not the reason why everybody stuck around, although I'm sure it helps. But no, that was a great presentation. Thank you both for such great information. I always enjoy listening to you guys speak, and especially love those demos. But yeah, so so I do want to thank everybody who did submit questions during the question and answer period. There were some really great ones that came in as well. So thanks very much. Just a quick reminder that today's event has been recorded. So if you missed any or all of the event, or if you just want to watch it again, you'll have the opportunity to do so. Following today's webinar, we are going to be sending out an email that contains a link to access the webinar on demand. The webinar is also going to be living on the devops.com website, so you can always go look for it there. Just go to devops.com/webinars, look in the on demand section, and it should be right there waiting for you. Let's see. Let's go ahead and do that ever important Amazon gift card giveaway, the moment that everybody has been waiting for. So without further ado, our winners today are Janet M. Congratulations, Janet. Second winner today is Ken R. Congratulations, Ken. Third winner today is William G. Congratulations, William. And our final winner today is Alex B. Congratulations, Alex. We'll be following up with all four of you via email to get your gift card over to you. So please check your inbox. If you don't see it there, please check your spam folder. Okay, Kendall and Ivan, again, thank you so much for a great presentation. Lots of good information in there. Again, love to hear you guys talk. It's always chock full of information. So, and if I got a lot out of it, I am sure the audience got a lot out of it too. So thanks again, really appreciate it.
Thank you very much. We appreciate everybody that joined and asked questions.
Right.
Thanks.
I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody, and please stay safe.